So a student has sent me these questions and asked for just more explanation of them, so I'll send this to everybody. We'll do some of this in class actually today. An 80 decibel should say sound right there, is how many times as intense as a 50 decibel sound? The decibel scale is logarithmic, so when I have an increase from 50 decibels up to 80 decibels, that is an increase of plus 30 decibels. And even though that's almost doubling the decibel level of the sound, it actually increases the intensity of the sound by a lot more. The way you find that is you do this. So I take this value. How much does it take to increase up to the new sound to the new decimal level? And I divide by 10, and I get a fact, and I get uh, divide that by 10, and that equals to 3. And then my answer is going to be 10 to this number, 10 to the third. And 10 to the third is 1,000 times as more intense. I'll only give you multiples of 10 for that, so it becomes a lot easier. And that's always the way you do it. You say, how much does it take to go from 50 to 80, or whatever your numbers are? Divide that number, which in this case is 30, by 10. That gives me 3. And then the increase in intensity is by 10 to that value, 10 to the third, or 1,000. Engine is 25% efficient in converting fuel to work. The engine does 50 joules of work. What is the energy of the fuel consumed by the engine? So 50 joules of work comes out. It's 1/4 of the total amount that's put in. Let's write that out as words. 50 joules is 1/4 of, or 25% of the total input energy. Okay, um, so we can write this as an equation. You probably did this in grade school where you can set certain words like is, 50 joules is, that means that it's equal to 1/4. And if I'm talking about a quarter of a total amount, that's going to be 1/4 times the total energy. And 50 is 1/4 of 200. Or if you want to solve this, I would multiply both sides by 4. That gets rid of that fraction right there. And 4 times 50 is 200. 200 joules then is the right answer. String on a guitar is a tension of 10 newtons. If I increase the tension to 20 newtons, by what factor does the pitch change? So want to look at the equation for that string on a guitar. Whoops. It's F equals 1 over 2L square root of T over mu. F is 1 over 2L square root of T over mu. If I increase the tension by a factor of 2, that is, I have a factor of 2 underneath there. In order to keep this equation balanced, I have to have a square root of 2. The reason it's square root of 2 is because this 2 is underneath this square root. So the answer is C for 21. You stand 1 meter from a point source of sound and the intensity is I. What if you move to a half a meter closer? So let's look again at that equation sheet. We're going to look at this in class today. The intensity is equal to this power over area, or power over 4 pi r squared. So the intensity is equal to the power divided by 4 pi r squared. And what I'm doing is I'm moving from 1 meter to a half a meter. That means that I'm halving this distance from r. That half is squared, it becomes a quarter, and it means that I'm increasing my intensity by a factor of 4. Right, because I is proportional to 1 over r squared. If I have that r, it becomes a factor of 4 increase in the intensity. So the closer you move to a sound, it's going to increase by a factor of 1 over r squared. It's an inverse square. The velocity of the wave is 2 meters per second. Its period is 2 seconds. What is the wavelength of the wave? A couple ways you can do this. Probably the easiest way to do this is to say that the velocity is wavelength over time. That's 2 meters per second. Um, is equal to the wavelength divided by the time to travel one wavelength, which is that period or 2 seconds. And then I can solve that for a wavelength and I get 4 meters. So C is the right answer. Another way to do this is to find the frequency, which we have to do for this question, by the way, same series of questions. The frequency is 1 over the period, and so that's 1 over 2, or a half a hertz. And then I can say that another way is I can say that the velocity is equal to the wavelength times the frequency. That is 2 meters per second is equal to the wavelength times a half a hertz. And so the wavelength is equal to 4 meters. You exert 4,000 joules of energy to move 10 kilogram object from ground level to a height of 40 meters. How much energy is required to move a 20 kilogram height to a height of 20 meters? Okay, so this was kind of a difficult question. I wouldn't ask you such a question, but let's go through it anyway. So notice here for this first one that the change in energy, I tell you, is 4,000 joules. And that's to move this 10 kilogram object. To change, let's calculate the change in potential energy for this object is m times g times h. That's 10 kilograms times 10 meters per second squared. That's g times h, which is 40. That's 10 times 100 times, that's 4,000. Okay, no, this isn't that difficult. So that means that I have 100% efficiency. That means I'm putting in 4,000 joules of energy in order to change the energy by 4,000 joules. So I have 100% efficiency. That means I'm putting in an amount of energy and I'm getting out that same amount of energy. So now how much energy is required to move a 20 kilogram object to a height of 20 meters? Well, I could do the same thing. The change in potential energy is going to be mgh. That's 20 kilograms times 10 meters per second squared times 20 meters. That's going to be 200 times 20. That's also 4,000 joules. So C is the right answer. Sort of a funny question. Still, it's not a difficult question, just asking what is the change in potential energy. But I don't know why I gave that stuff in the beginning. Yeah, okay. I think that's all.